Hello friends, I am your maths faculty from QLS Academy. Friends, today I am going to start a new topic and that is factorization. We already learned about factors in class 6 और हमने natural number भी पढ़े. Natural numbers are those number which are used for counting, that is 1, 2, 3 and etc. Take any natural number, say 20. अब हम इस 20 को लिखने के बहुत सारे तरीके होते हैं. हम बहुत सारे तरीकों से इन 20 को लिख सकते हैं. जैसे 20 is equals to 2 into 10. 20 can also be written as 20 is equals to 5 into 4. We can write 20 as 1 into 20. Thus, 2, 10, 5 and 4 are the factors of 20. A number written as a product of prime factor is said to be the prime factor form. For example, 30 written as 2 into 3 into 5 is a prime factor form. The prime factors of 70 is 2 into 5 into 7 and the prime factor of 90 is 2 into 3 into 3 into 5 and so on. We should remember that prime factor के हम और further factorization नहीं कर सकते हैं. Similarly, we can express algebraic expression as the product of their factors. This is what we shall learn in this chapter. Now, let us understand factors of algebraic expression. We have seen in class 7, in algebraic expression, terms are formed as a product of factors. For example, in an algebraic expression 5xy plus 3x, the term 5xy has been formed by the factor 5x and y. That is, 5xy is equals to 5 into x into y. Observe that the factor 5x and y of 5xy cannot be further expressed as a product of factors. We may say that 5x and y are the prime factors of 5xy. In algebraic expression, we use the word irreducible in the place of prime. We say that 5 into x into y is irreducible form of 5xy. Here we should note that 5 into xy is not an irreducible form of 5xy, since the factor xy can be further expressed as a product of x and y, that is, xy is equals to x into y. Now, let's understand what is factorization. When we factorize an algebraic expression, we write it as a product of factor. These factors may be numbers, algebraic variables, algebraic expressions, expressions like 3xy, 3x square y, 2x in the bracket y plus 2, 5y plus 1 x plus 2 are already in factor forms. These factors can be just read as we already know. On the other hand, consider the expression like 2x plus 4, 3x plus 3y, x square plus 5x, x square plus 5x plus 6. It is not obvious their factors are. We need to develop systematic methods to factorize these expressions, that is, to find their factors. That we will do in this chapter. Let's move to method of common factor. अब हम एक simple example लेते हैं. For example, factorize 2x plus 4. We shall write each term as a product of irreducible factors. That is, 2x can be written as 2 into x and 4 can be written as 2 into 2. Hence, 2x plus 4 is equals to 2 into x in the bracket plus 2 into 2 again in the bracket. Notice that factor 2 is common to both the terms. Observe, by distributive law, you can see here 2 into x plus 2 is equals to 2 into x plus 2 into 2. Therefore, we can write 2x plus 4 is equals to 2 into x plus 2. That will be is equals to 2 into x plus 2 in the bracket, as you can see. Thus, the expression 2x plus 4 is same as the expression 2 into x plus 2. Now, we can read off the factors as they are 2 and x plus 2. These factors are irreducible. Now, we will take an example of factorize 5xy plus 10x. The irreducible factor form of 5xy and 10x are respectively the 5xy is equals to 5 into x into y and 10x is equals to 10 into x. Observe that the two terms have 5 and x as their common factors. Now, 5xy plus 10x is equals to, in the bracket, 5 into x into y plus 5 into x into 2. That will be 5x into y plus 5x plus 2. We combine the two terms using the distributive law as shown. The 5x into y plus 5x into 2 is equals to 5x into y plus 2. Therefore, 5xy plus 10x is equals to 5x into y plus 2. This is the desired form we want. Now again we will consider an example. Factorize 12a square b plus 15ab square. Here we have 12a square b is equals to 2 into 2 into 3 into a into b, and 15ab square is equals to 3 into 5 into a into b into b. The two terms have 3, a and b as a common factor. Therefore, 12a square b plus 15ab square is equals to 3 into a into b into 2 into a in the bracket plus 3 into a into b into 5 into b again in the bracket. On combining two terms, we have 3 into a into b into in the bracket 2 into a plus 5 into b. So, we will get 3ab into 4a plus 5v, that is 3ab multiplied by 4a plus 5v, which is the required factor form. Now, factorize by regrouping terms. Look at the expression 2xy plus 2y plus 3x plus 3. You will notice that the first two terms have common factor 2 and y, and the last two terms have the common factor 3. But there is no single factor common to all the terms. How shall we proceed? Let us write 2xy plus 2y in factor form. 2xy plus 2y is equals to 2 into x into y plus 2 into y. Therefore, we will get 2 into y into x plus 2 into y plus 1. That will be, finally we will go, that will be 2y into x plus 1. Similarly, 3x plus 3 is equals to 3 into x plus 3 into 1. That will be 3 into x plus 1 is equals to 3 into x plus 1. Hence, 2xy plus 2y plus 3x plus 3 is equals to 2yx plus 1 plus 3 into x plus 1. Observe, now we will have the common factor x plus 1 in both terms on the right hand side. Combining the two terms, we will get 2xy plus 2y plus 3x plus 3 is equals to 2yx plus 1 plus 3 into x plus 1. So, finally, we will get x plus 1 into 2y plus 3. The expression 2xy plus 2y plus 3x plus 3x is now in the form of product of factors. Its factors are x plus 1 and 2y plus 3. Notice, these factors are irreducible. Now, we will study what is regrouping. Suppose the above expression is given as 2xy plus 3 plus 2y plus 3x. Then, it will not be easy to see the factorizations. Rearrange the expression as 2xy plus 2y plus 3x plus 3. Allow us to form the groups such as 2xy plus 2y and 3x plus 3, leading to factorization. So, this is regrouping. Regrouping is possible in more than one form. Suppose we regroup the expression as 2xy plus 3x plus 2y plus 3. This will also lead to the factor. Suppose we regroup the expression 2xy plus 3x plus 2y plus 3. This will also lead to the factors. Let us try 2xy plus 3x plus 2y plus 3. Here we will get 2 into x into y plus 3 into x plus 2 into y plus 3. That is x into 2y plus 3 plus 1 into 2y plus 3. That will be is equals to 2y plus 3 into x plus 1. The factors are same as they have to be, although they appear in different orders. Now, we will consider an example. Factorize 6xy minus 4y plus 6 minus 9x. The solution will be step 1. Check if there is a common factor among all terms. There is none. Step 2 is think of regrouping. Notice the first two terms have a common factor 2y. Therefore, 6xy minus 4y is equals to 2y into 3x minus 2. That will be our equation 1, or you can say equation A. What about the last two terms? Observe them. If you change their order to minus 9x plus 6, the factors 3x minus 2 will come out. Minus 9x plus 6 is equals to minus 3 into 3x plus 3 into 2. That will be minus 3 in the bracket 3x minus 2. That will be our equation B. Now, the third step, putting A and B together. Here 6xy minus 4y plus 6 minus 9x is equals to 6xy minus 4y minus 9x plus 6. That will be 2y into 3x minus 2 minus 3 into 3x minus 2. Here we will take 3x minus 2 as a common. So we will get 3x minus 2 into 2y minus 3. The factors of 6xy minus 4y plus 6 minus 9x are 3x minus 2 and 2y minus 3. Now moving to our next method, that is factorization using identities. We know that a plus b ka whole square is equals to a square plus 2ab plus b square. A minus b ka whole square is equals to a square minus 2ab plus b square. And our third equation is a plus b into a minus b, that is equals to a square minus b square. The following solved example illustrate how to use these identities for factorization. What we observe in the given expression, if it has a form fits the right hand side of one identity, then the expression corresponding to the left hand side of the identity gives the factorization we require. Let us take an example. Here factorize x square plus 8x plus 16. The solution will be, observe the expression, it has the three terms, therefore it does not fit into the equation third. Also its first and third term are perfect square with a positive sign before the middle term. So it is of the form a plus b ka whole square is equals to a square plus 2ab plus b square, where a is equals to x and b is equals to 4, such that a square plus 2ab plus b square is equals to x square plus 2 into x into 4 plus 4 square. That will be x square plus 8x plus 16. Since a square plus 2ab plus b square, by comparison we will get x square plus 8x plus 16 is equals to x plus 4 ka whole square. That will be the required factorization. Now moving to the next method, that is the factor form of x plus a into x plus b. Let us discuss how we can factorize expression in one variable like x square plus 5x plus 6, y square minus 7y plus 12, z square minus 4z minus 12, 3m square plus 9m plus 6, etc. Observe that these expressions are not of the type a plus b ka whole square or a minus b ka whole square. That is, they are not perfect square. For example, x square plus 5x plus 6, the term 6 is not in perfect square. These expression obviously also does not fit the type a square minus b square either. They however seems to be the type x square plus a plus b x plus a into b. We may therefore try to solve the identities we studied at last chapters. X plus a into x plus b is equals to x square plus a plus b into x plus ab. For that we have to look the coefficient of x and the constant term. Let us see how it can be done with the following examples. Factorize x square plus 5x plus 6. If we compare the RHS with previous identity x square plus 5x plus 6, we can find ab is equals to 6 and a plus b is equals to 5. For this we must obtain a and b. The factors then will be x plus a and x plus b. If ab is equals to 6, it means that a and b are the factors of 6. Let us try a is equals to 6 and b is equals to 1. For these value a plus b is equals to 7 and not 5. So the choice is not right. Let us try a is equals to 2 and b is equals to 3. For this a plus b is equals to 5 exactly as required. The factorization of the form of expression is then x plus 2 into x plus 3. Friends, this is all for this chapter. For further information or you have any kind of doubt, please go through the following link. Thank you.